Alright, so these are reaction balancing problems. And we'll take a look at this one first. The only thing we're allowed to do when we're balancing reactions is to put numbers out in front of compounds. So all we're really doing is just changing the number of moles of each compound we have in the reaction. We'll learn more about moles later, but all we're doing is just changing basically the numbers in front here. We can never, for example, change that HCl to H2Cl2. That just changes the compound completely then. So I can change the number of molecules I have, but I can't change the actual molecules themselves. Alright, so going over here, I've got two hydrogens, and I've only got one hydrogen over here, so I put a 2 in front of here. But when I do that, now I've got two Cls, but over here I've got two Cls and Cl2, so that seems to have balanced out okay. So these will remain 1s, and we'll have 1, 1, and 2, and that one will be balanced. Okay, looking at the next one, we've got 110 and 110. We've got 1 Cl2, and over here we've got 4 Cls. So what I'm going to have to do to balance that out is to put a 2 in front of a Cl2, and that's going to give me 4 Cls. Now, if you're not sure if you believe me, 2 Cl2s will look like this. This is 1 Cl2, and that's 2 Cl2. So you can see I've got those 4 Cls, and you know that an SnCl4 will look like that. It'll look like an SN with 4 Cls next to it. So you can see everything balances out with the chlorines. Alright, so now you can see that we haven't changed anything else. So we've got 110, 110, 2 Cl2s, that's 4 Cls and 4 Cls. So we're balanced there, 1, 2, and 1, and that would be it. Okay, so for the next one, we've got 1 potassium and 1 oxygen. So let's see, we've got one O2 over here, I should say, and we've got a K2O here. So we've got 1 K and 2 Ks. So in order to balance that out, what I might do is put a 2 in front of here. And then I look at the oxygens and I say, okay, I've got 2 oxygens here, and now I've got 2 oxygens, now I've got 1 oxygen here. So I need to put a 2 in front of here. So I do that, now you can see that I've actually got 4 Ks. So I'm going to have to change that 2 to a 4. And that's going to be a 1. Now, just in case you don't believe me, 4 Ks would look like this, and 1 oxygen would look like this, and K2Os, and there's 2 of those, and you can see that I've got 2 oxygens here to match that one, and I've got 1, 2, 3, 4 Ks to match the 4 Ks over here, so you can see that that's going to be balanced. Alright, so let's look at this one here. We've got lead 4 nitrate and sodium nitride, and what we're going to do here is we're going to treat the NO3s as their own singular little unit. I'm not going to split this up into separate nitrogens and oxygens, and here's why I can do that, because I've got NO3 here and I've got an NO3 over here. That means that nothing's sort of going to change between them. It's almost like you can treat that like an X or some sort of group or some sort of atom rather than just a separate nitrogen and 3 oxygens. So here's how I'm going to do this. I've got 1 lead here and I've got 3 leads here. So what I'm going to go ahead and do is put a 3 in front of here like this. Okay, so the leads are all balanced. That's not a problem. Now look what we've done to the nitrogens. We've got 3 times 4 is 12 NO3s. Now, just in case you're not sure of what I'm talking about, what I'm going to do is I'm going to get rid of all this stuff. And I will draw out for you 3 PbNO3 So this is one of them. And this will be 2. Oops. And this will be 3. So that's what 3 PbNO3 would look like. And you can see that there's a total of 12 NO3s there. So in order to balance that out, what I'm going to have to do is put a 12 in front of the NaNO3. But now look what I've done. I've got 12 NO3s, but now I've got 12 sodiums. How do I fix that? Well, over here you've got 3 sodiums. If I put a 4 in front of here, Now I've got 12 sodiums and I'm good. But look, now I've got 4 nitrogens. But over here I've already got 4 nitrogens. So this is often the way that things will pan out. You'll balance everything up, and then the last thing, which in this case was the nitrogen, you'll find is already balanced at the end. And 90% of the time that's what's going to happen. In fact, if that doesn't happen, I think I'd be looking to see if some mistake hadn't been made. Alright, so we've got 3, we've got 4, this will be left with 1, and that'll be 12. And that's how we'll find the coefficients of that particular one. Alright, let's take a look at the next one. We've got PbNO3 and we've got Na3PO4, Pb3PO4, and NaNO3. And in the same vein as what I was talking about earlier, I've got 1 lead, and I've got 3 leads over here, so I'll put a 3 in front of here. We've got 3 PbNO3 that's a total of 6 NO3s, so I'll go ahead and put a 6 in front of here like this. That means I've got 6 sodiums over here, so I'll put a 2 in front of here like this. Now it's going to give me 6, and that gives me 2 PO4 groups, and over here I've already got 2 PO4 groups, so that one's balanced as well. So that one's balanced in pretty much the same way as that one is.